From yesterday's class onwards, we are discussing the problems on gravitation, right? Yes or no? So in yesterday homework or in worksheet, I gave 3 questions. Okay, so those are the questions from the application of concepts in your textbook. Okay, so let us discuss the problems which are given in the application of concepts. Okay, in your textbook. Okay, so first one, a car moves with the constant speed of 10 meter per second in a circular path of radius 10 meters. Okay, and the mass of the car is 1000 kgs, and how much is the required centripetal force for the car. Okay, so we have to find the centripetal force. Okay, so I already gave the derivation for the centripetal force formula. Okay, what is the formula for centripetal force? See, first write the given data. Okay, so what he given? Car speed. Okay, so how much is the car speed? 10 meter per second. Okay, and the next radius of the circular path he given. Okay, so radius of circular path. Okay, so radius of the circular path, capital R, is equal to 10 meters. Okay, and next, mass of the car. Mass of the car is equal to 1000 kg. Okay, and what is the formula to find centripetal force? Fc is equal to mv square by r. Okay, so here m is the mass of the object which is moving in the circular path, and v is the velocity or speed. Okay, and next means it is revolving, or it's moving in the circular path, right? Each and every time it changes its direction, right? Yes or no? Okay, so that's why these it is said to be velocity. We have to take the speed as a velocity. So v is equal to speed or velocity is equal to 10 meter per second. So try to substitute here mass 1000 kg into velocity 10 into 10. Okay, and what about radius? Radius r, that is 10 meters. Okay, so 10 and 10 will be cancelled. Next, 1000 10,000 newtons, that is equal to 10 power 4 newtons. Okay, centripetal force. Okay, centripetal force Fc is equal to 10 to the power of 4 newtons. Okay, and the next problem, let us see. What is the speed of an apple dropped from a tree after 1.5 seconds, and what distance will it cover during? See, second question. What is the speed of an apple dropped from a tree after 1.5 seconds? Okay, and what is the distance it will cover during this time? Here we have to solve 2 questions. So we have to find the speed of the apple and also distance it will cover during this time. Okay, so see, it is falling from a tree means initial velocity. Okay, so that is u is equal to 0, right? Yes or no? So while dropping any object, if you are dropping from a certain height, means we have to take initial velocity 0, because it is at a constant position. So after dropping it will attain some speed. Okay, that is final velocity we have to find, or even he give final velocity, he may ask time and like that. Okay, so next, how much time he given? 1.5 seconds. Okay, so t is equal to 1.5 second. So and g we have to take 10 meter per second. Okay, and next we here is asking speed, right? So we have to find a final velocity. So these are the available values, and these we have to find. So you know already about these 3 questions, right? V is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. So try to select the suitable equation from these three. So here if you observe the given values and what is the value we have to find. So see, by combining these four values, this is the perfect equation we have to take. Okay, so v is equal to u plus at. Okay, so here u0 plus a 10. Okay, meter per second square, and t value 1.5 seconds. Okay, 1.5 second. 1 second, second will be cancelled here. 10 into 15 means a 15 meter per second. What is this final velocity? Okay, so the speed of the apple. Okay, the speed of the apple is equal to 15 meter per second. So we used the first equation. See, already said while selecting the equation we have to see the what are the given values and what we need to find. So if you see here u t g v here, and g and in place of a we will take g. So v value we have to find, u given, a, t also have. So this equation is suitable here. So we are applying first equation. So this is the velocity, final velocity. So now let us solve the second question. So that what is the distance it will cover during this time. So distance he is asking. For distance, s is distance, right, in the both equations, the second and third. So here try to check the values. U we have, time we have, a we have. So we can apply this, right? Yes or no? So try to see, in this case you can you may apply both the equations. Okay, so even first and even second we can apply, because we u to a s we have to find. So I am applying, or I am selecting the second equation. Okay, so I am applying second. Even you can apply third also. Okay, so s is equal to ut plus O of at square. Okay, so u here 0, right? 0 into t, that is 1.5 seconds. 0 it will becomes half into g or a 10 into 1.5 into 1.5. Here how much you will get? 2 5s. So if you multiply 0 plus 5 into 1.5 into 1.5, you will get 11.25 meters. Okay, so this is a distance, right? Okay, so distance covered by the apple. Okay, distance covered by apple. Okay, so apple is equal to 11.25 meters. Okay, so next let us see the third problem. These are the homework questions only. Yesterday I gave 3 homework questions, right? So this is the first question and this is second question. So let us see the third one. Okay, so a ball is projected vertically up, okay, with the speed of 15 meter per second. So find the maximum height, the time maximum height. Find the maximum height it reaches, and also time to reach the maximum height, and the speed at the maximum height. Here we have to solve 3 questions. So let us see. First, let us write the question. A ball is projected. See, a ball is projected vertically. See, means initially it is with the it is rest. So we have to give some velocity so that it will go up. Okay, so that's why it is projecting up with the speed of 15 meter per second square. Means initial velocity here 50 meter per second square. Find the maximum height. Okay, here height means nothing but distance we have to find, and we already know hit the maximum height. Okay, the speed is 0, right? Yes or no? So here final velocity, that is v is equal to 0, we have to take. Okay, and here we need to find a distance. So what is the suitable formula here? So we have a u, that is initial velocity 50 meter per second. Okay, 50 meter per second initial velocity we have, and at the topmost or at the highest or at the maximum height, what happens? Final velocity becomes 0, and we already know g value we have to take, that is 10 meter per second square, and we need to find the s. Okay, s height is nothing but s we need to find. So by these four values, which formula we can use? V square minus u square is equal to 2as we can use. Okay, and here we are throwing upright, means we are throwing a stone or a ball opposite direction towards to the gravitational force. So we have to take a g value minus. Okay, so g is equal to minus 10 meter per second square. So here v0, right, 0 square minus u 50 square is equal to 2 into minus 10 into yes we need to find. So here minus and minus will be cancelled, and 50 square means just write 50 into 50 and divided by 20, that is equal to s. Okay, so here we need to get s is equal to 0 0 cancel, 2 25 25 5 how much, 125 meters. Okay, so the distance, what is the maximum height? So maximum height, that is s is equal to 125 meters. Okay, so next time. Okay, we need to find the time to reach the maximum height. Okay, so by, let us see the maximum time. Okay, so time is nothing but just we have to apply first formula, v is equal to u plus a t. Okay, because so we know final velocity, initial velocity, even a value or g value. So find 0 is equal to 50 into plus minus 10 into t. Okay, that is equal to minus 50 is equal to minus 10t, minus minus cancel, 50 by 10 is equal to t, 0 0 cancel, t is equal to 5 seconds. Okay, so this is the time taken to reach the maximum height. And next, speed at the maximum height, we already know that speed at maximum height is equal to 0. Okay, speed at maximum height is equal to 0. Okay, so this is the third question. Okay, in yesterday's homework question. And so next, see next problem. See next problem. Two spherical balls of mass 10 kg each are placed with their centers 10 meters apart. Okay, 10 centimeters apart. Find the gravitational force of attraction between them. Okay, so next question is two spherical balls. Okay, two spherical balls of mass 10 kg each are placed with their centers 10 meters apart. Find the gravitational force of attraction between them. So here force of attraction, we derived the equation by the universal law of gravitation, right? Yes or no? So what are the given values here? Masses. Okay, two objects masses, that is m1 and m2 is equal to 10 kg. Okay, and distance is equal to 10 centimeters. And the next see let us write the formula. F is equal to capital G into m1 m2 by d square, right? Yes or no? So G is universal gravitational constant. So G value we already know, that is 6.7 into 10 to the power of minus 11 Newton meter square per kg square. Okay, substitute these values here. Okay, so F is equal to 6.7 into 10 to the power of minus 11. Okay, mm, Newton meter square per kg square into m1 10 kg into m2 also 10 kg. This kg get cancelled, and the next d square, that is 10 centimeters, right? Okay, 10 into 10 centimeter square. Okay, so see here what is the left value. So let us convert these centimeters square into meters. So 1 meter is equal to how much? 100 centimeters, right? So 1 centimeter is equal to 10 to the power of minus 2 meters, right? Yes or no? Substitute here. 6.7 into, see 10, this is 10 square we can write, right? Okay, 10 to the power of minus 11 into 10 square into Newton meter square by here, 10 square into 10 to the power of minus 2 whole square, meter square, meter square cancelled. So what is the left here? 10 power to 10 power to cancel, this bring upside. So 6.7 into 10 to the power of minus 11 into 10 to the power of 4. Okay, newtons he will get. So F is equal to how much here? 6.7 into 10 to the power of minus 11 into 10 to the power of minus 4 newtons, that is equal to 6.7 into 10 to the power of 11 minus 4, how much you will get? 7. 10 to the power of minus 7 newtons over 10 to the power of minus 4 g newtons. Okay, this is a question. Okay, so the remaining questions today I will give as a homework, and tomorrow I'll explain the solutions for them. Okay, so this lesson is very very important. Try to listen. If you miss any video, go to my YouTube channel Anu Teki and try to listen all the videos, and see if you have any video you can text me. Okay, and thank you.